Hi, I'm Cath and I'm based in the Systems Oncology group here at the Cancer Research UK Manchester Institute. In Systems Oncology we study pancreatic cancer. I work on tumour heterogeneity. Heterogeneity is where we assess the variation across a tumour. So that might mean the cells in the tumour, so immune cells or stromal cells, but for me primarily it means the tumour cells themselves. How are they different across a tumour and different from one another? And I'm primarily thinking about how that difference might drive different responses to therapy and development of resistance. Working on pancreatic cancer is quite difficult. I hear a lot of emotional stories from people when I tell them what I'm working on. A lot of them have had family members that have passed away very rapidly, and that's kind of a big hallmark of this disease. You're typically diagnosed at a late stage, which can limit your treatment options. Very few patients are eligible for surgery, and the chemotherapies, systemic therapies that are available really lack of effectiveness, and so that's really what we're kind of aiming to improve. So we use mass cytometry to study pancreatic cancer because the tumours are very diverse. There's lots of different cell types, a big stromal compartment, so lots of fibroblasts, but there are also some immune cells as well. And the tumour cells only kind of make up about 20% of the total tumour mass. And so mass cytometry allows us to look at that composition of the tumour at a single cell level and what's going on exactly in there. Computational methods and programming came to me when I was kicked out of the lab basically because of the pandemic, and we were all stuck in this situation where we weren't able to do our wet lab experiments, and so we looked for publicly available single-cell RNA-seq data sets or other mass cytometry data sets we had in-house that we hadn't yet analysed, and I learned how to do the analysis for these big complicated data sets, and this really got me into programming, and it's enabling me to develop to become part of an interdisciplinary team in the future. I've been able to attend a bunch of seminars and meetings and conferences online that I just wouldn't have had the opportunity to go to in person. So, for example, I went to two really good modelling courses. One called Finder in the Modeller, would have been hosted in Chicago, and the other was hosted by the European Bioinformatics Institute called the Mathematics of Life. And I was able to really key in and learn lots of great stuff. Another big highlight for me was attending the International Student Cancer Conference online. This is a conference that our institute is a part of, and I'm really hoping to attend in person next year when it's hosted in Heidelberg. So looking back at how I was when I started the PhD, I think I've grown in so many different ways. There's a lot of growth obviously that happened on the technical side, like you've just developed lab skills, you've developed a sense for experimental planning and analysis, but you also develop a lot more. You learn how to cope with failure, you learn how to celebrate your success and measure your own success. You kind of really develop all of these soft skills. You can work in a team really well, your communication skills are massively improved. I look back at some of the early talks I did in my PhD versus the talk I did at the colloquium this year, and the skills I've developed in communicating my science has just drastically improved. Systems Oncology is a fantastic group. We all work really well together. They're really good at supporting you when you're having a bad day. There's always a good laugh going on in the lab, and yeah, I'm really great at encouraging one another, and there's always cake. If you come into the Systems Oncology office, there will probably be cake.